economics. We're going to talk a bit of economics. And I have a number of lectures through the week. So each one will build on each other and feed into each other. So sometimes I'll repeat some things. So please bear with me.
Especially, I can't believe I'm going to tell you of all people, but I can't hear you.
Really? Oh, is this alive or dead? Okay, you know what? I don't like being that rock star like Priscilla. Hey, you need to switch it on.
There we go. There we go.
I needed Lisa to help me with that.
Yes, there you are. Yes. Anything else I can do?
Oh, no, you just go have it. Sit down and rest. All right, so how many of you have a degree in economics here? One. Oh, no, Chris, stop that. So no degrees in economics. How many of you have a course in economics? Okay, oh, that's quite good. It's fantastic. Okay, so at least there's quite a number of who have economics. So what I thought I would do is, knowing that many of you don't have a degree or something, just to throw out a few terms that you would have heard about already. In economics, you can't talk about economics without talking about supply and demand. So the market is run by supply and demand. If there's a lot of demand for something, it has a say on the market. And if there's too much supply, and if the market supply and demand balance, then you have a different kind of market. So that's an important concept. So if you guys, you are beginning now, it's a bit too late. If you're in high school and you are deciding what to do, which area will you go there? You go to where there is a lot of supply or less supply? You want to choose your career, where do you go to? Where there's a lot of supply relative to demand? I see you're saying no, right? So the lawyer, the philosopher, who is the philosopher? You guys are doing amazing stuff, I think. You're going to shine compared to the rest of philosophers and lawyers, right? Because you're doing something unique. Scarcity, that leads to scarcity. And you all have heard this invisible hand business, right? Have you heard about that? Yes, that's Adam Smith. That's the most famous economist in the world, even today. He died a long time ago. He's a philosopher, economist, and everything, yeah. So combining philosophy and economics, he did a lot. And one of the things he's known for is this idea of the market has an invisible hand. If you let the market, it will do everything for you as you would never have imagined. It's almost magical, and some people believe in this a lot, and so argue for only the market to decide everything. But he wrote a lot. It's not just this. He's actually a philosopher. He also talks about the state, how you need to manage things because the market alone cannot do it. So that's important. Opportunity cost, that's a big concept. Who can tell us what that is? I try to be quite interactive, so who can tell us what opportunity cost is? Some of you took economic courses. Oh. Yes, please, go ahead.
It's like the cost of doing the thing you want to do and foregoing the thing that you didn't choose.
Okay.
Added together.
Yeah. So see, a key example is you guys are here in this room now, and you're going to be here for the next 1 week. You know what it tells me? It tells me that as far as you can tell, this is the most valuable thing you can do with your week today, this week. All the alternatives are less valuable, otherwise you wouldn't be here. So the opportunity cost of you being here is the next best thing you could have done with your time. Because that's the value you are forgoing, actually. So in economics, this is crucial. You talk about opportunity cost. If you have no opportunity cost, then you are not valuable. That's how brutal it is, It's crazy, but actually, in practice, you see a lot of that. Incentives are crucial in economics because we believe this is the driver of human behavior, right? And it doesn't have to be money, it doesn't have to be It's anything you care about, anything you like and anything you don't like can be used as an incentive, as a way to get you to do certain things. So governments use that to do that in fisheries. So if you want to fish illegally, and you are in Indonesia, and your fisheries minister is Susie, you are in trouble, right? So that's a very strong negative economic incentive. If she catches you, your boat is going to go in flames, and so on and so forth. That's a serious incentive scheme to keep you away, right? Yeah. If you want people to do certain things, you give them positive incentives, right? And examples, so economics talk about it. Division of labor is another concept that underlies a lot of the thinking in economics, and what is that? Division of labor. Let's talk. The idea that to get the most from any group, you let people do what they are best at in the group. If you do the best you are best at, and he and they, then cumulatively we are getting the most from everybody. That's the concept of division of labor. So that means different people will be good at different things, and they will get more. In a static sense, this is a good concept, but I don't like it in a dynamic sense, which is quite surprising to many economists. Because what it means is that if we start today, and what you're good at is cleaning the floor, if you think dynamically, that means you have to keep cleaning the floor forever to the end of the world, which is crazy. Right? If you think dynamically, you want that person to learn skills so he or she can move up or do something else. So in a dynamic sense, I don't like it. But in a static, if we're all just today, it might be useful. So it's a comparative advantage just comes. The two go together. If you're good at something, that means that you have a comparative advantage. And this concept has been used in the world actually to keep some countries, not to keep them to countries to be hewers of wood. You heard that and so on. So if you're a developing country, you're good at cocoa, just farm your cocoa, ship it to us, and we'll make it into chocolate. So that's so it can be used as always good or bad. Watch out for that. And then in economics, we talk a lot about marginal output, the marginal revenue, the marginal cost. Economic decisions are actually made at the margin. It's weird, but it's very powerful. So, for example, if you are producing something and your marginal revenue, that is the revenue you get for the next additional unit you produce. If that is positive, then you keep producing more, right? Because it's giving you more at the margin. But if it's zero or negative, you stop. So you usually use the margin to decide whether to continue doing what you're doing or not. And that is important. And I thought I should throw in taxes and subsidies. Actually, they connect a lot to incentives. And democracies, at least government, use subsidies and taxes to get people to do things, because you cannot force anyone to do anything. Right? You don't use the gun, so you gotta do this. But you can use subsidies. If we want people to drive less, we make it cheaper for them to use public transport. So we subsidize public transport. See? If you want people to smoke less, what do? You tax cigarettes. You make it more expensive to smoke, and then it's also. So these are just a few things I thought I should drop out, just because of the different backgrounds, just to give you some general principles. Okay. Point number one. Second point, why are we concerned about the ocean, especially the fish? So I thought I should quickly highlight some of the things. The ocean provides a lot of food for us, nutritional, good food, better than beef, according to the medical people. And many of you who deal with fish, usually you have your fish. If you're a biologist, you follow a species or something. Even economists do simple models, single species and so on. But if you think globally, we take out, on average, about 110 million tons of fish each year. Right? Can you imagine how much that is? From the ocean. I'm not talking about agriculture or inland fisheries. 110 million tons of fish. Now, because fish are generally small, sardines and anchovies, we cannot imagine how much mass we pull out. But if you change this to the number of mature cows, okay, that is about 110 million mature cows that we take out of the ocean. If you assume a mature cow is 1 ton, which is generally the case. So think of the world, seeing us taking out 100 million cows from the ocean each year. There might be an outcry actually. That is more than all the cows we slaughter on our farms globally. I think that's about 60 million mature cows or cows. So just to give you the importance of this. Economic security, jobs, 260 million people draw some income from ocean fisheries and keeps a lot of young people employed. And that's something, to me, that's probably the most useful service the ocean gives us actually, not the dollars. Just keeping young people in large developing countries busy, because without it, the opportunity cost is very low, as you know, because they don't have alternative skills. And so recreational values, cultural values, spiritual values. I had a student who studied spiritual values in British Columbia, and they found evidence of that. People go to the beach and they put their legs in the water and they just feel relieved. You swim and you feel good, right? So that is, and then there are lots of other ecosystem services. Beth gave you that slide with all the blue economy movement and so on. So there's a lot more than fish. You know? This is why we all care. I mean, we care about the nature, but nature does a lot of things for all of us, and that's even a stronger reason for many people to really care about this. We take a lot, and the oceans are under threat. Climate change is one of them. I'll get to that, but this is the kind of headlines you see in the news, and when the newspapers start doing this, you know there's trouble, right? They're usually slow, especially when it's the environment. By the time you start seeing these headlines, so changes are happening. It's not like they're going to happen. I just read in the headline during lunch, some paper has just come out. In northern China, not too long from now, it will be very risky for people to stay outside for more than 6 hours a day because of the projections of climate changes they're seeing. This is the latest Missouri checks here, and you see that. And 6 hours, you can't do more than 6 hours, you're out, you get eaten up by the bad climate environment. So these things are happening. Now, connected to the talks we've had so far is the issue of climate change. All these have been mentioned. There's the average sea surface temperature above the long-term average, so the more reddish, yellowish it is, the more it is higher. We talked about the warming with less sea ice, and our famous debate of last time when we met, whether the ocean is acidifying or more acidic. We had a debate, and where is Lauren? He beat me hands down, even though I have the better argument. You see? So you can lose the debate, you know, at the moment, even if you have a good argument. Right? Lauren, you gave up on that, right? Then the less oxygen and all that. So as these things are happening, as an economist, I'm sitting down and I'm thinking, my God, if all these things are happening to the physics and chemistry of the ocean, sea level rise, like Priscilla explained to us, this is going to impact the ecology and the biology and the animals in the ocean, right? At the individual level, growth, physiology, body size, populations impacted, communities of species, even whole ecosystems can be impacted. So if you're a social scientist or an economist, you see this, you say, hey my God, there's going to be trouble to people because we depend a lot on this system. And so here, this is an idea I've been playing around with in terms of framing a simple model. Yeah? And here you see that there are two This is conservation of the ocean, or sustainability of the ocean. And here is the size and distribution of ocean benefits that is we take out of the ocean. And I put distribution there because it's important. It's not only about the size of the cake, but how the cake is shared is also very important. And so what I'm saying here is climate change can directly impact the conservation, as you have seen. Body sizes of animals becoming small because they have to reduce a lot of energy to deal with warming rather than growing, for example. So there is a direct impact. But this also can directly impact the cake, the culture, so on, and all other functions, oxygen. You know that half of our oxygen comes from the ocean, and a lot of this is from what? Plankton and zooplankton and the lower living things, right? So we can be impacted directly by it. And this thing, the way we handle climate change, we might be able to move this into a positive kind of situation. If we do the RCP 2.6, for example, at least, that will help us directly improve on this and on this. And that can help us, we'll have a positive feedback. But if we don't do the right thing, we get into the negative feedback. More CO2, more climate impacts on the ecosystem means less fish. So we fight for the little fish. There will be wars, and I'm not joking. There can be wars, and there have been indications of that. And this then leads to further less fish, less cake, and even worse distribution. And that is very scary. So the stuff we are doing here is really fundamental to the long-term survival of people on this planet, really. It's like we're joking, but this is serious stuff. We can turn it in a positive way, or we just loop it in the negative way. And the sad thing is, it's easier to get into the negative feedback loop than the positive one. You need a lot of work to get into the positive zone. But the negative, even when you are sleeping, is happening, right? That is why it's dangerous, right? You know, there's every reason not to do anything today. It's remarkable. Inertia is part of human tendencies. Yeah. So, having said all this, here is a very simple bioeconomic model. This is the simplest bioeconomic model you can see. The bio is the biology. So you have a biological model. And this equation here, as simple as it is, that is all of biology of fisheries actually. Yeah. And they're so simple. You see that? You want to know how much, yeah? Isn't that cool? This is what mathematics can do. They can reduce the world to one equation. Yeah? Yeah. So net annual change in biomass of your fish depends on the natural growth of the fish, the new fish that comes in, those that die, because this is renewable nature, and the fish we take out of the system. That's the master equation of every fisheries model you touch your hands on. It gets complicated and very, you can see models you don't want to read, like Greek, right? But really, that's the underlying thing. And the economics is even simple. Oh my gosh, that's all the economics. I tell them I learned all my economics in grade school. One of my teachers, she taught me, you know, profit is selling price minus cost price. You remember that? That's it. Economics is done. So that's the equation. Net revenue is your sales income minus your cost. So the question I have for you, all that you had in the morning up to now, if you look at this model, how is climate change likely to enter this model? At which points? So this is a little exercise for you. And how? Somebody wants to start? Huh? All of them. Ah. So you can affect the growth. You're a biologist, you know this stuff. Yeah. The recruitment, new fish coming. The natural mortality. How is that likely? That with climate change, fish can die faster or not die faster? Who knows? Right? An intrinsic growth rate can be impacted. Your mortality rate can be impacted. high temperature. In fact, people too, where did I live? Was it India? There were hundreds of people who died this year actually because of heat wave somewhere in the world.
Well, there's also that science paper that the guy from Stanford came out with, that the rates of suicide are increasing.
Oh my God, I read that. That was quite scary. The higher the temperature, the more suicides. Yeah, that's a very recent paper. And this is a beautiful paper actually. I liked it a lot because it comes from nowhere and it hits you from your head. It's beautiful. This is the kind of work you should be doing. I hope you do as you go. You just think of something, use your skills, and get it on and get it out there. And before you know, the whole world is talking about it. This is what I love about our work. I was playing around with closing the high seas to fishing. When I said this in around 2004 or 2005, I said this to our group in the fishery center. Even Daniel probably thought I was crazy. Nobody will know, what are you talking to me? And now, after keeping on, it's amazing where it is going. People are talking about it, including high level. So, please, that was thank you for mentioning that. So you can be captured. And in economics, the topic is impacts of climate change on the economics, but actually, economics impacts a lot on the system through climate change, right? A lot of our trouble is actually coming from our economic activities, right? We pump in CO2, so we produce all the things we want or need, right? So there is connection. Okay. Simple model, so that as it gets complicated, you are rooted in this. And usually, to really get a good paper, even a complicated one, you start with a simple caricature model like this. Get the concept properly in your head, and then you can blow it up and make it as complex as possible. It will be grounded, at the end of the day. So productivity will be affected. The thing you don't see in that simple model is the distribution of the fish. Even if you don't die or you don't lose weight or so on, temperature forces the fish to either move. That's what the science is saying, and our group at UBC has been big on this, led by William Chang. So as it gets warmer, fish are moving with the temperature. If you remember when you came in here, and I had that feeling after lunch, I felt so good, right? Yeah, so that's it. The fish don't have air conditioners. They don't have where to hide in an air conditioned room. They either follow the water, the temperature, or they perish if they can't. And that is what you see in the distribution, and therefore it affects the balance. So, as I'm saying, all this will end up with people. Your catches will be affected. Some may get more fish, actually, like the Icelandic and Norwegians, because the fish are moving up there. For a while, they can expect to see more fish, but who knows what happens next, right? But for most places, there's going to be declines in catch. And therefore, the food security and the quantity of the fish that comes out goes down. There will be less fish to eat. The revenue, the money you make, this is standard value or catch value is the revenue you make from catching the fish right at the top. So you use expensive prices to do this. Cost of fishing likely to change. For many places it will be more expensive, you have to go out. But some may be lucky, the fish may actually come closer to shore. So you need to analyze this in order to really know. And with all this happening, your profitability will be impacted, incomes to fishers, and the distribution of the benefits, of course, will also be impacted. We have a cool paper which is under review now. I'm not going to tell you anything more than that, where we actually tracked not just the revenues and as I'm going to show you, but the profit, incomes to people, the amount of money we pay consumers, and so on and so forth throughout the economy. So hopefully we'll get it published in a decent enough journal so more people will see it. Yeah. So now what I'm going to do, I'm going to show you two case studies we have done very quickly, and then So to do the models I'm going to show, we use the RCPs, and we've heard a lot about them already, thanks to earlier speakers, RCP 8.5 and 2.6. So we just have two contractual models to make life easy, right? You have lots of models in which we just took this and we play around, develop high economic or ecological economic models to help us nail this. So this is little schematics. So if you have an ecological model, an ocean model, that tells you what is happening in the ocean, with the physics and chemistry and all that, and you can feed that into a fish model, which of course has all the other things that you need to be able to model it. Then you can predict catches, given the temperature and so on and so forth, and ocean acidification. So this is the thing that underlies the modeling work we do. And if you have that, once you have that, then you can build. So this is the distribution of the species, the catch, species composition. Then you get into the economics, right? How will that affect your gear composition? If you used to catch big fish, and suddenly you have small fish because of climate change, or you have jellyfish, and you need to really keep, right, to be able to do it. So that can change. The catches will be different. That can affect the prices you get, and so on and so forth. And so you build a model. This thing has its own minuses. So that is just a simple illustration. And the paper I told you we were working on, we took things further. We didn't just stop at the profit, but we went through the economy, all the added value, right? Income to workers in the fisheries sector, household budgets and so on. So it's very comprehensive analysis of the economics. So this is a little framework of the ecological economic model. And then we use it to come up with results such as this one, which is work led by Vicky Lam, my former PhD student. This is part of her PhD. And that is the changes in the revenue and catch. So here we have percentage change in maximum catch potential. So this could, you could just see this as the MSY, the maximum sustainable yield, and then the percentage change in maximum revenue potential. So we summarize these two here. So West Africa, for example, see that there's going to be a big effect. In fact, not only West Africa, that's here in the tropics, and this was the point you were making, right? And you have some countries having a bit of famine here, and fish are moving up, following the temperature, at least for a while. And here we notice the average percentage change in NCP of about 7.7% negative. This is global average value. Some areas will be positive, some will be more negative. Overall, it's a negative thing. But the impact on the revenue is even bigger. It's over 10%. So this tells you in a very simple way, not only is the total mass of fish being taken affected, but the quality of the fish we take also changes. Quality in the sense of the value per unit weight. So you are getting more jellyfish, for example, right? Just take it to the extreme instead of salmon or tuna. And that is shown up here. There's a lot in the paper that you can grab, but this is a basic finding which matches the movement and the impacts on the ecology of the fish. So here we did some sensitivity analysis, because really the price of fish doesn't depend only on the catch from the wild, right? It depends a lot on agriculture. Agriculture is really contributing a lot now. So we played around to see how our projected revenue changes is likely to change given different scenarios of agriculture development. Baseline, current situation, 13% drop. that if we have a faster expansion in agriculture, prices could actually go down, right? Even with climate change. So that's the thing. And remember, I was just doing scenario analysis because agriculture is not immune to climate change on all of it. So that might temper this, but this is just to give it to you. So here we talk about lower production in China. If for some reason, because China is really agriculture. Did you know that? What percentage of global agriculture is China, produced by China? Does anybody know?
50?
50. Yeah, that's a good and close enough case. It's 60%. So in the presentation, I think this was in Washington I gave last week for this one, I told them that if the world was divided into continents according to the quantity of farm fish the continents produce, there will be 2 continents in the world, China and the rest of the world, and China will be the bigger continent. So that's how big it is. So we played around with this scenario. If there's a slowdown in China, even if the world is to, the rest of the world is to expand, there will be an increase in the price of fish. So we played around. Initially, we did this to make reviewers happy, but actually it was a useful exercise, right? So don't get angry with the reviewers. Just try to get the best messages and make your paper better, because in the long run, at the end of the day, most want to improve your paper, okay? Sometimes I get angry myself. So this is about fish meal and slow agriculture. So we just did a bit on this just to illustrate. And what we see again and again is actually the big impact in the tropics. And this thing really keeps making me unhappy actually, because I find this troubling, ethically troubling actually. And this is an illustration of that. Change in fish revenues, and this is low human development index. Most of you know about the HDN, right? It's put out by the United Nations. It's supposed to be broader than the GDP. It has the GDP in there, but they have 2 other indicators in there, like birth 1 year, the mortality for kids before they hit 1 year. And so they capture a broader set of human development aspects. And what we do is that we put the countries, so you have low HDI countries, mostly developing countries, and the higher ones develop. When you do this, and this is the revenue gain or losses, if you look here, you see mostly developing countries. You have Marshall Islands, Tuvalu, and now those small Pacific Island states. And when you look here, you see Greenland and Iceland, they're getting more fish. So developing tropical countries pump out less CO2 per capita, but are hit more, and they also need fish more than people in the north. You can find alternatives very quickly. If you're living in Vancouver and there's no fish, you find something. But if you're in West Africa, Southeast Asia, and there's no fish, you're in trouble. So for me, this is such a powerful thing. Outside of economics, really, it's ethical, it's moral, it's fairness, and so on. Difficult to talk about in today's politics, but still worth mentioning. Yeah, that's it. It's one of the developing countries. So that's one of the case studies that I thought I would show you. Now the paper is out, it's open access. And scientific reports is one of those open access things. You can get hold of it from anyone. Now, the second case study, this is an interesting one. I got a call from one of our local credit union banks, Van City. It's called Van City. It's a local bank, really deals with communities, gives people small loans and so on. And they have shown a lot of interest in trying to inform the people of Vancouver and British Columbia about big issues happening around the world. So they came to me and said, this climate change is a big thing, but people in Vancouver can't even relate to it. They read all these big papers, but it doesn't, they don't know how to get hold of it. So what can we do to make Vancouver and BC people really realize this is serious? And then we end up, I suggested, how about we try to calculate the cost in the household fish budget of residents of British Columbia. So it's due to climate change. So very interesting little paper. The day we published the report, it was unbelievable. And I was busy from 6 a.m. to about 9 p.m. Radio interviews, television. Everyone wanted to hear about this. So I'll be doing interview in taxi from one radio house or TV. It was unbelievable because people, it's their pocket, you know. So this was quite powerful. And now we're doing this at the global scale. In fact, that's the global paper I mentioned earlier, which is underway. So that's BC and Canada. You have the Pacific Coast. And here you have the US. The border is here. Most Canadians are hanging on the border. What percentage of the population is right there at the border? Maybe 80–90%. It's amazing, actually. So what I did, together with Vicky Lam, what we did was to say, what are the 10 big species that people in British Columbia actually spend money on, the fish they consume? And these were the 10 that showed up. And this is the tonnage, the amount of fish we consume per year in British Columbia, of prawns, hake, crabs, and so on. Let's see whether soca is big better. So this were the things. So we took these species and ran them into the ecosystem models and then came up with some numbers. But there was a twist there. Because, yes please.
Are these fished in British Columbia?
Are they in British Columbian waters?
Yeah, these all.
Not all of them, and I'll come to that. That was what I was saying, there was a twist to this, right? And that was one thing we did in the study, which I thought was quite powerful. So we looked at the total consumption, and the next question we said is how much of this is coming from the waters of British Columbia? How much is coming from the rest of Canada? And how much is coming from the rest of the world, right? Because we consume fish from all over. And what did we find? Here, this is not very clear, but here, there are sources of seafood, British Columbia waters, from our local waters. That is the total amount in tonnage, and that is the percentage seafood consumption in British. So about 32% of the total consumption comes from British Columbia waters in Pacific. Then you have the US, so about 21% comes from the US. And the rest of Canada contributes nearly 10%. And so on and so forth. But see here, you have Thailand, China, Peru, Chile, and other countries. So I made a big number with this. I said, hey, British Columbians, when you think of climate and you think of what is happening in your waters, but that is not enough. You have to care about what is happening in the rest of Canada. And also in parts of the world where your fish comes in. You see that? So you take a little study and you make a big point that actually reaches out to the whole world, which is, I think, very important for climate change. So that answers your question, right, Poliano? And so this element was taken in. The good thing is we have global models and regional models. You have another question. He knows a lot about this model, so let's go.
No, I'm just curious on what's the updated list of most consumed of the ones fished in BC just
You mean after this work?
No, like from that 32%, that is, like how does the list of those three?
Oh yeah. In the paper you'll find that. I don't know whether I have them here because this is not the detailed presentation, but sure. Do you know the paper? We actually publish it. My God, he's sitting in my building and he doesn't know this paper. You're in trouble, man.
I publish like 5 per day.
And that is the problem, right? So he's good. He always comes back. He's one of our many top smart students, right? They always come back with things, which is nice. So just to give you a little bit about the model, So we look at the current price of seafood, and we connected changing the supply and the climate change to the prices of fish. So how sensitive are fish prices to changes in supply of BC waters and the others? And we use price elasticities and even what are called price flexibilities. It just tells you the proportion. If you reduce the supply by 1%, how much will the price change of a given fish species, right? So we use that to help us nail down the effects on BC. And this is a very quick summary of some of the results we are seeing. If you look at this, the supply of almost all of them goes down. This is both local and imported fish. Only rockfish, for some reason, rockfish love climate. They did well. And all the others is negative. And this was one of the reasons we got so much attention. In British Columbia, salmon is king, and sockeye salmon is even a bigger king, right? So, traditionally and otherwise. So, we projected a change of price of up to, if I remember, 21%. And this was really a big shock for the province. And that was why the attention was so much. And here you have change in the price per kilo of the fish of the different key species. And in there, Vicky put on the change in cost per person. Essentially what we found was that for all of us in BC, this climate change could lead to an increase in our household budget for fish by $65 million. And this is no small change, even for British Columbia, right? And so you've got a lot of attention here.
Seems like a lot of that would be driven by prawns, because but a lot of prawns, I'm assuming,
come from
are
us.
farm raised.
Oh, farm, yeah.
Which wouldn't really factor into.
Okay, that's a good point. You know, this is only the prawn that comes from the sea that we have in the morning. Yeah. So this we captured it with the aquaculture business, the scenario I told you. Yeah.
Okay.
Yeah.
Okay.
But this is a good point. Yeah. And finally, what we were talking about doing, and this together with Stanford Ocean Solutions and our group, is actually to bring in aqua and bring in wildlife in a much broader. It's going to go crazy, but you know, people keep asking us how about agriculture. So this little paper, it was unbelievable the kind of impact we got. So that is the second case study summarized for you very quickly. We have a report, we're turning it into a paper to publish now. That's why we say it's in preparation. Okay, so the rest of the slides I have general stuff, like the impact of climate change on food security. And yeah, as you know, fish, I said, is healthier and more protein, all the micronutrients and so on. And when I put this graph, I said, just look at that hog. Can you imagine how happy they are to have their fish? It's nice to see this, right? Just so happy to have the fish. But although we are saying climate change is likely to impact this, especially in the tropics, and that's another figure, stimulating potential catch. And actually we started, so the polls. But again, this is, if you think of Lauren, your talk, right, with all the other things happening, the oxygenation, the ocean acidification, and so that was why I was asking you about where the hotspots are. Because the Arctic is one of the hotspots of ocean acidification because of many factors. So when I think of that, you know what comes to my mind? It's almost like fish running away from boiling water here and jumping into acidic water. Huh? Just think about that. And I don't know. Running away from warm waters into more acidic. And so, scary. Okay. So this is another thing we're doing to try to change this into the distribution of fish protein available for people to eat. And again, you see the big impact on the tropics again, which is reinforced in the earlier point about this. I worry about this a lot. And this is just the fish. Agriculture is also impacted. And this is the part of the world where food is actually needed. Malnutrition is more. And you may think that if you are in Canada or in the US or in Europe, you are far away from this problem. No, you are not. We are all well, right? We've been following what has been happening with immigrants, right? From West Africa, forced migration actually. Many of them would be happy to stay at home, but they're forced out. What are the consequences of this? Even wars, I don't think can deal with that. We need to use our brains as the world population to deal with that. This picture was something I got, I think it was a Washington Post. And that kind of, to me, captures some of the things we are talking about. Where food is needed, food is running away and being messed up by climate change. In some cases, moving to where there's food. So here you have women body mass index and men body mass index. And this is plotted by continent: Africa, Asia, Europe, North America, Oceania, South America. And you see what the pictures are. So here, you see many of the developing countries are here, right? Where they don't have this belly here that I'm carrying. This is more in the rich part of the world where you have obesity and so on. So, another dilemma. Rashid shouldn't get more food actually, right? Who am I to say that? So that's one aspect of food security and so on. The other thing is management. And we've done a paper about this, and there's more coming. In fact, William and Co. had a paper recently in Science Forum where they talked about management is moving as fast as the fish are doing. So so the complication is also in management, how we manage, whether we can adapt fast enough to match with the fish. So here, you have, this is the country's waters. That's the original distribution of fish. And then you have another country sitting here that used not to have fish, right? So there's no fish in the waters or different types of fish. And then you have warming and all the things happening. And that then affects the distribution. Oh my dear. So the fish moved to this one, right? And this is not a joke. This has happened. Mackerel. I think you mentioned mackerel. Is it, Beth? Did you? Yeah. So the fish are moving. And what do people do? So you have. Oh, I'm going backwards. It seems. So you have this one. You have invasive species. And then you have local extinction here of some species. What are the consequences of that? And I could do that too. So, and then you have all the changes we talked about happening there in the two countries. And what happens to management? What are the consequences? A lot of things can happen here, scenarios. If this is a big country, that is very powerful, there can be different consequences, right? Imagine that this is China or this is the US. They say, don't touch that fish, it's our fish. If you do, we blow you up. Yeah, this is a scenario that I also do. And then if it's on the other hand, if this is so I say, this is the weak country, so you can't do it, but if it's, you know what I'm saying. So this can mean a lot in terms of management. Yeah, so we did some modeling. Even within countries, this is not a given. This is a prediction of where the revenues will be, and the severe climate change and mild climate change in Mexican waters. So see here, all these are negatives. So some of these places will have more fish. If you are somebody, a villager here fishing, do you just move to this place just like that? You think it will be easy? So even with big countries, this is not easy. That's the mackerel example. And yes, and so I have to put this slide here. I talk to you as if I know everything for sure. I don't. Nobody does. There's a lot of uncertainty. And in the papers, we make sure we talk about this. Ranges, prices, I don't know, I didn't tell you that. There are all sorts of places where our predictions can go wrong. And that is all right. That's okay. You do your best, put it out there, you see what life really turns out. So there are conclusions here, things I've said already, in terms of the revenue, developing countries, prices in DC, pressure, and so on. And yes, and the need to do things, take action. We'll talk about mitigation and adaptation together in this course. And I always like to talk about solutions. Solutions to me start from individuals. Okay. So I start from here. And that feeds into what businesses do. If you refuse to buy stolen fish, then there will be no market. They will stop doing it, for example. NGOs have something to say, and government, the way we vote and we do our advocacy can affect how we manage our oceans in the face